Good morning, everyone. Today we're going to be looking at the 9.4 notes. We will split this lesson into two parts, so this will just be kind of the start of it. But we're looking at composition of transformations. Our objective in this video will to be able to draw glide reflections and other compositions of isometries in the coordinate plane. So when a transformation is applied to a figure and then another transformation is applied, the result is the composition of transformations. The first composition of transformations we're going to work on is called a glide reflection. And that's the composition of a translation and a reflection, line parallel to the vector. So a really good example of this, footprints left in the sand. Those use a glide reflection. You translate the footprint along the vector, and then you reflect it over a line, and there's where your next footprint would be. Alright, so we're going to be working on these in the coordinate plane here. We're going to work on a glide reflection in the coordinate plane. So, triangle JKL has vertices 6, -1, 10, -2, and 5, -3. So here is triangle JKL. We do our, that's not a pretty good triangle, but we do our best to connect it. All right, and then we want to graph its image after a translation along 0, 4, and then a reflection in the y-axis. So we're going to translate this along the vector 0, 4. So if we remember doing that, if we have point J, which is at 6, -1, and we want to translate it along the vector 0, 4. Okay, again, we add 0 to the x-coordinate, add 4 to the y-coordinate. That would give us J prime is at 6, 3. And so we could plot that point. I'm going to use our color here, 6, 3. That's now point J prime. And then we want to move point K, and so in the same manner we take 10, -2, point K, we add 0 to the x-coordinate, add 4 to the y-coordinate. K prime would be at 10, +2. And so we plot the point 10, +2, that's K prime. And again, this is just after the translation. We're also going to have to reflect it here in just a moment. And so last point L, 5, -3 in the same manner. Add 0 to the x-coordinate, go to the y-coordinate. L prime is at 5, +1. And so we plot that to 5, 1, L prime. So this is after the translation, and clearly you can see all those points just moved along the vector 0, 4. They moved up 4 units. All right, and then now we want a reflection in the y-axis. Remember, reflections, guys, we're just, and especially in the coordinate plane, unless it's along y equals x, in the coordinate plane, we just want to know how many units it is away from where we're reflecting it. So if we're reflecting it across the y-axis here, we want to know how far each of these points is to the right. All these points are to the right, so we can find out how far they are to the right of it, then we can just move them that far to the left. So 1, 2, 4, 5. L is 5 units from the y-axis, so if we go 5 units to the other direction, 1, 2, 3, 4, 5, there would be point L. We'll just use double prime there. All right, and then so we do the same thing with J. We see that J is 6 units to the right, so we need to go 6 units to the left of the y-axis. That would be J double prime. K is out here, it's 10 units to the right, so we need to go 10 units to the left of the y-axis. And there would be K double prime. And so our green triangle, that is, again, after we translated it, and then we reflected it across the y-axis. So this is our final outcome, and all those ordered pairs there would be correct. So that's a glide reflection. So this next one, we're going to do another composition here. The endpoints of CD are -7, 1, negative 3, 2. So we want to take this segment CD, and we want to graph its image after reflection in the x-axis and rotation 90 degrees. So first thing we should do, let's reflect across the x-axis. Again, the x-axis is our horizontal axis. So if we're going to do that, well, we see that C is 1 unit above it, so the reflection of C would be 1 unit below the x-axis. D is 2 units above the x-axis, so the reflection of that would be 2 units below the x-axis. Right, so that was after reflection. Now we want to rotate those points, so we want to rotate the point negative 7, negative 1, that's C prime, and then we want to rotate the point D prime, which is negative 3, negative 2. And we want to rotate these 90 degrees. So if you remember your rules of rotation, a 90-degree rotation takes the point x, y, and it maps it to negative y, x. So that's the pattern there for rotation. So if we apply that to these 2 points, C double prime becomes, we're going to change the sign of the y value, and then move the x to the y. And then D double prime here would become 2, negative 3. And so if we plot these points, 1, negative 7, I've got to scroll a little bit. 1, negative 7. That would be our point C double prime after that rotation, 90 degrees. And it would go 2, negative 3. That would be, and so now this new segment, C double prime, D double prime, that is our segment we were looking for. That's the image here. It was after a reflection in the x-axis and a rotation 90 degrees. All right. All right, so that's going to finish up this video for today. We will work on the other composition of transformations in another video tomorrow. Thank you all for watching. Have a wonderful afternoon.